Hello and welcome. In this lecture, I want to describe some of the data types that I mentioned in our last lecture. Data types, remember, they're important because you have to provide this when you declare a variable. And they tell the actual compiler how much memory you want to create. So it's specific to size as well. So the compiler needs this information. But let's talk about the ones that are supported by the C programming language. So we know, up until this point, we know that C has many different types of variables that have different types of data. Right? We know that from creating and initializing variables. You can have types that store integers, numbers essentially. You can have types that store non-integer numeric values, things like scientific notation, or things like what we'll talk about Booleans, which is true and false values. And then you also have data that needs to be stored, such as characters, either a single character or many characters, which is referred to as a string. But we know that we have these different types of data. Again, for a C program to be powerful, it's going to need to manipulate data, and it's going to need to manipulate all different types of data. So some of the examples that C supports, the basic data types, there are many data types in C, but the basic ones that we're going to talk about today in this lecture are the int. And remember, these data types are special keywords. So when you say int in a C program, the compiler is going to know that, oh, this is a data type. So we want to talk about int, float, double, char, or char, and bool, underscore bool. These are the main ones that you're going to use, and then there's different variations off of those depending, again, on the type of data you want to store and how big the data is. So the difference between these types is the amount of memory. That's all the data types in specifying the data types is about. It's about the memory that needs to be allocated. And it varies depending on what type of architecture you have. But the memory and the amount is going to determine the range of the values that can be stored. So the amount of storage that is allocated to store a particular type of data is important to the compiler. It all depends on the computer you're running, and this is referred to as machine dependent. So if I run a C program on a Linux system with different hardware versus a Windows system with certain hardware, an integer may be 4 bytes in memory, or it may be 8 bytes. Again, it depends. So it's dependent on the machine you're running at, how much memory is allocated depending on the data that you want to store. So, you know, an integer might take up 32 bits, which is 4 bytes. Or it might take up 8. So first, let's talk about the int. This is one of the most widely used data types. It's a data type that can store integral values, values that do not contain decimal places, whole numbers. This is when you would identify this data type when you create a variable int to store a number. You can also put a minus sign preceding the data type in the variable, and that indicates that the value is negative. So if you have a minus sign preceding the actual literal. So what I'm talking about here is when you create the variable and assign it data. If you put a negative number, a value, it's a negative number. So ints can store negative numbers is basically what this is saying. It's also a signed integer. We'll talk more about what that means. But a signed integer just means that it can be either positive, negative, or 0. And that's why you can put a minus in front of it. If an integer is preceded by a 0 and the letter x, so here we're talking about constants. Here we're talking about when you assign data to an int. Right? I'm trying to describe to you the type of data that can be stored in here. And so when you assign data, we know how to assign data to variables because we learned that earlier. We just define the data type and then we assign it using the equals operator. Now you can assign values to ints. You can either assign numbers, which is the most intuitive and easy way to do it, like 15. But you can also assign hexadecimal numbers. The computer and the programming language allows that. If you want to assign a hexadecimal number to a variable that stores an integer, you just put the 0 and the x before. And that tells the compiler that this is a hexadecimal number. Hexadecimal numbers is base 16, so you can store letters A through F. So hexadecimal looks like 0xFFEFOD. So you may see this occasionally in your program where somebody's assigning a hexadecimal number, and you're probably thinking to yourself, well, an int only stores a whole number, but it can also store different representations. And so this is one with 0x preceding it. The values 158, -10, and 0 are all valid examples of constants that you can assign to integers, integer variables. There's no embedded spaces are permitted between the digits. Right? And if you try to assign a value larger than 999, you can't use commas. So don't try to assign a value to a variable like named x with 12 comma 1000. You have to 12 comma 000. You have to do 12,000. Float, another really important data type, one of the basic data types. This is a variable that can store data for floating point numbers, which means numbers that contain decimal places. So values like 3 dot, 125.8, and -.001 are all valid examples of data that can be assigned to variables of type float. Floating point constants, which is the values that you assign, can also be expressed in another notation. It's called scientific notation. So you can assign a value like 1.7e4 to a floating point variable. And that's just going to mean that it's represented in scientific notation. The C compiler understands it. It represents the value as 1.7 times 104. A double, very, very similar to the float. It stores decimal numbers, decimal places. The only difference is it's larger. So you can store larger numbers. And again, so that would mean that it collects more data in memory. So you want to use a double whenever the float is not sufficient. It's too small. So a float, I think, stores like, say a float stores, depending on your architecture, say a float stores 8 bytes. That means it can store values from like -32,000 to a +32,000. If you try to represent that same data in memory using a double, you can then store even higher numbers, right? So you want to use basically twice as many significant digits, going long as long, millions and millions and trillions, whatever, much bigger than a float. So most computers represent a double value using 64 bits, which is 8 bytes. Doubles are usually, or floats are usually 4. Doubles are 8. I might have misspoke there. And that just means you can store more data. And the way that you would create the variable is you would say double keyword before naming the variable. All floating point constants are taken as double values by the C compiler. So that's by default. If you specifically want to make something a float, you just add an F2 at the end of it when you assign it. So to explicitly express a float constant, just put that F there, 12.f. Underscore bool. This is a data type that can be used to store just the values 0 and 1. You'll often hear this term Boolean expression. In bool, it all means true or false. It's a yes or no, 0 or 1. So it's indicated for binary choices, essentially. And we're going to talk a lot about Booleans and Boolean expressions when we talk about decision statements. Boolean variables are used in programs that need to indicate a Boolean condition, a true or false type of answer. So for example, a variable of this type might be used to indicate whether all the data has been read from a file. Yes or no. Has all the data been read from a file? If it's 0, yes, or 0 false, 1 yes, which we'll talk about now. So 0 is used to indicate a false value. 1 indicates a true value. So even though it's true or false values, the way that the data is stored in memory is 0 or 1 as a numeric. But the numerics mean that 0 means false, 1 equals true. So if you were to print out Booleans, you would see values 0 and 1 printed out, not true and false. But they mean true or false. They only can have 2 values. So here's an example with some data. Let's go ahead and put this in code blocks and see how we do it. So here again, we have our basic program and we have our main routine. We know how to declare variables where we have to provide the data type. Now we know how to declare more than one. Before, we only declared an int. Now we can actually declare something like a float. And you just use the float keyword. And IntelliSense will help you. And then you follow the naming conventions. Let's just say, again, Jason. And then we can assign it a value. Floats consist of decimal places. So we could say, 23.22. And that contains a float, and we assign it. So we're initializing and creating a data type, a variable of type float that contains value 23.33. And you notice the semicolon at the end there. We can do the same for double. We have to come up with another name. We could say Jason2. We want to have meaningful names, though. We know that. Here, it would just be a larger number. So it'd be like, so many. And we could also express this with scientific notation if we wanted. We could put an E here, plus 11, but that big, large number would not be able to be stored in a float, and that's why we'd use a double. We can create a bool, underscore capital B, or capital B, and then an OOL. Oops. And here, just, bool variable. Usually you want a camel case. And then here we could just say true, even though it doesn't necessarily contain that when you print it out, or we could set it to 1. And then you always want to compile and run your command. The bool type also usually has been aliased to other names, so you don't always have to just use underscore bool. It depends on the compiler you're using. This actually compiled fine. It just says I'm using unusing variables, which gives warnings. But they usually have aliases, so you can just say bool as well. So you don't have to do the underscore capital B. The underscore capital bool, though, is just used as a standard, but bool looks fine. It also highlights better. So bool variable is still of type Boolean. So very easy to create different variables of different data types with these basic data types: float, double, bool, and int. Now let's go back and talk about other data types that aren't used as much, but are kind of variations of these 4. So other data types, you may ask yourself the question, well, hey, why do I need more data types? I pretty much talked about numbers. Why do I need to represent numbers in different ways? So we still haven't talked about characters, which we're going to talk about, and there's some other data types. But as far as numerics goes, we've talked about numerics being decimals or non-decimals, ints, doubles, and floats. And you would say that probably is enough. And typically the int is enough. All you need is an int. You'll use an int quite a bit. But C is a flexible language. And as one of its advantages, there are many other data types where you can represent other integer types. And it gives some flexibility to the programmer. Depending on the use case, depending on the data, it allows it to be even more precise. So this is one of the ways that C can become even more efficient. If you have something very, very specific, you can specify a specific data type as part as an integral or an integer, and it will make the program run quicker. So it gives the programmer options, flexibility with additional data types. Integer types can vary in ranges, and whether negative numbers can be used. So some of the data types I'm going to talk about in terms of integers, but these also apply to floats and doubles, are some keywords that you can assign to the int already, but it's not always required. So you can basically have more specified versions of ints, more specified versions of floats or doubles. Or you can use these keywords by themselves. So for example, you could say short int. That's a data type. And I'm going to tell you what that means. Or long int, or unsigned int, or short double, or long double. These are all additional data types with these 3 adjectives. But you also don't need to use the int, float, or doubles with them. You could just say short, or you could just say long, or just, and that will provide specific data that you can store. But this is all about being more precise and making the program more efficient. Again, you'll probably just use int, double, and float for the most part. But when you start getting more advanced C, you're going to start using short, long, and unsigned along with the int, double, and float. So for example, type short int or short, just short by itself. Like I said, you could use both. It uses less storage than an int, so it can save space. So if you're writing a program that needs a lot of memory and you need the program to be efficient and not use a lot of memory, you can create shorts. So it allows that flexibility. It makes your code more efficient if you use a short as opposed to an int. You don't have to use a short, but it will use less memory. And the same goes for longs. They use more memory, and it's actually larger data. So a long int is going to use more storage than an int, allowing you to store larger integer values. Or you say long float. Or you can just say long by itself, and that will be a larger integer value that you can store. You might ask yourself, why not use a double? Because a double, remember, has decimal spots. So you may want to store an int that's just a really large int. You can use long. So a type long int, another type, or long may use more storage than a long. And again, it all depends on the computer platform you're using and the architecture. You can assign values of these different types. A lot of them have different letters that you can append. So for example, here, if you're assigning a long constant value, you just put the capital L or the lowercase l at the end of it. And that will assign that value as a long. Same goes if you're doing some of the shorts. You can also apply suffixes at the end to make sure that the compiler explicitly knows what you're dealing with. So type specifiers can also be applied to doubles, as I mentioned. These shorts and longs, you can say long double. And here we create a long double called USDefs 2017. You can, for the long doubles, you can use the capital L, as I mentioned, or lowercase l, same way you would with the ints. As far as the other data types besides short and long that we talked about, concerning unsigned, you can set the prefix unsigned to ints, doubles, or floats. And this is used for only variables that have non-negative values. So remember that an int can store not negative numbers. You just say minus. If you don't want a int to store a negative number, you can declare it as an unsigned int or just unsigned. And that will make sure that everything assigned to that is positive. Now, that's how it works in theory. Some compilers don't enforce it. But if you were to create an unsigned int and you tried to assign a negative number, the compiler should complain. So unsigned int counter, for example. And again, this allows the accuracy of the integer variable to be extended to only allow positive values. So it's making your program more efficient by using all of these different data types, these more specified data types for these. Also, there's the signed data type that can be applied to ints, floats, and doubles, or shorts, signed short, signed int. It can be used with any of the types to make it more explicit, the intent. Signed shorts, signed ints, signed shorts, short ints, shorts, they're all the same. Signed means that it can be negative and positive. So these are just the basic data types that I wanted to talk about. These are the ones you're going to use most of the time, along with a couple more that I'm going to talk about in the next lecture. You usually don't have to get into using shorts and unsigns and longs unless you are more advanced C and you're trying to make your program more efficient. But all these data types, they're provided right before the variable name when you declare the variable. And then when you assign data to these variables of these different types, you can use suffixes like capital L or lowercase l to have explicit intent. Thank you.